In theory, today should all be review. In theory, you spent a little bit of time doing this in Science 10, and then you spent like 2 months doing this in Physics 11. We're going to do it in a class. Velocity, acceleration, and displacement. You may want your formula sheet, either the yellow one or the blue one in front of you, or you may vaguely remember this. It's really up to you. Acceleration. Acceleration is defined as a change in velocity over a change in time interval. In math notation, we write it this way. Acceleration equals change in velocity over change in time, although I should also then add the vector notation.
Can I just steal
Sure.
And Kevin?
Sure. Okay. In fact, I think I'm almost wearing part of that on my shirt right now today. You'll see I got the delta V, delta T, acceleration. What is the delta a symbol for? Change in. And something worth remembering is that change in anything is final minus initial, because we're going to be doing lots of change-ins this year. And if you know whenever you see a change in that it's, hey, just final minus initial, great. We can also write it as acceleration equals V final minus V initial. And then we get sloppy with the time, because time is always a change in. We get a bit sloppy and we drop the delta in front of the t, because there's no way to do a time without a final and an initial, without starting and stopping. So that's just kind of over the years, get tired of it. If I want to, I can rewrite this formula. I can get the V final by itself. I can times by t plus the VI over. This is the one that's on your formula sheet. This is the one that you probably remember from last year. VF equals VI plus AT. However, Brett, this assumes what we call uniform or unchanging acceleration. If you have the acceleration that's changing, it gets ugly. In fact, that's when you start to need calculus. Okay. If we do have uniform or unchanging acceleration, we can also find the average speed, which is written as V average, or sometimes written as V with a bar above it. Not an arrow like a vector, but a bar above it. Well, how do I find the average of anything? Sebastian, if you have $10 and I have $20, what do we average between us? Oh, he even gave, you hear it? He didn't give me the answer. He actually broke it down, because usually the kid says 15, and then I say, well, how do you find that? And they say, oh, I add them together and divide it by 2, which is how you find the average. The average velocity is going to be the final and the initial divided by, how about not by t, Mr. Dewick, divided by 2. Also on your formula sheet, yes? There's 4 equations in this unit. For what it's worth, if you're accelerating at a constant rate, then Chase, that average velocity occurs halfway between the minimum and the maximum velocities. In other words, if you accelerate for 5 seconds, your average velocity occurred at 2.5 seconds. That comes in handy every once in a while. It's one of those things that's nice to have in the back of your pocket that you pull out like once every couple of months. Distance. Distance is defined as average speed times time, or in symbols, V bar times t. And since I just finished saying that V bar or average was equal to that, we can substitute it in there. Oh, and Graydon, since V final is the same as VI plus AT, I can plug that in for V final. If I do that, I get something that starts to look kind of messy. I get this. D equals, instead of V final, I'm going to write VI plus AT, and then there's plus a VI, and that's all over 2 times T. Oh, What's 1 VI plus 1 VI? Those are like terms. If I gather like terms, what is 1 VI plus 1 VI? Oh, so I can go like this. 2 VI plus AT times T over 2. Now I think I'm going to distribute. I'm going to take this T and I'm going to multiply it into the brackets. When I do that, I'll get 2 VIT plus AT squared all over 2. And some of you can see where we're headed, where we're going. Sam, what's in the denominator? What's in the bottom of this fraction?
2.
Hey, let's divide this first one by 2, second one by 2. In fact, let's split it up. I'm going to write it like this. D equals 2 VIT over 2 plus AT squared over 2. Because if I'm dividing a fraction by 2, that's the same as dividing everything in the upper numerator by 2. Oh, Akemi, in this first term, how many 2's on top?
1.
How many on the bottom? They cancel. In fact, I end up with this. VIT plus AT squared. You know what? Instead of writing over 2, how did we write it last year? We put a 1/2 in the front. Okay? There's where the distance or the displacement equation comes from. I've done it with scalars. It works with vectors. Mr. Dillek? Yes, Dylan. Do we have to know how to derive? No, but I'll almost always show you where stuff comes from because I'm a nerd. Not always. Every once in a while you hear me say, you know what, the math to get here is yucky. Trust me, it works. So finally, we can put it in this box right here. D equals VIT plus 1/2 AT squared. That's the scalar equation. Or we can add the vector bars. Displacement equals velocity times time plus 1/2 times acceleration t squared. Ta-da! Sorry, Yu-Chen, but it says ta-da in big letters. Of course I'm going to yell it. You awake now? There you go. The last equation that we're going to be using this unit is a bit yuckier to derive. So here, Dylan, I am going to wimp out. VF squared equals VI squared plus 2AD. It's easier to derive from kinetic energy. It pops out there quite nicely. Let's do some examples. I have a couple of acronyms I teach my students that I stole from another teacher who was a good physics teacher. These are my problem-solving strategies, and the first acronym is DFIC. Does anybody of my students remember what DFIC stood for? Let's refresh your memory. DFIC stands for list your data. If you're not sure what to do, write down what they gave you. It's no longer blank grade and you feel better. It's a dumb strategy, but it works. As soon as you've written something down, the juice starts flowing from your hand to your brain. You do better. F stands for, hey, find an equation that has all of the stuff that you know in it. Oh, and if it also has what you're trying to find, even better. Insert the numbers, insert the data. And then calculate. So acronym number 1, Sean, when I'm solving a problem, DFIC. Now, eventually there will be certain questions that you've seen so many times that you start to take shortcuts. You may go straight to formula insert. You might not even list your data. And in your homework, I say, great. If you get that good and that confident, excellent. You know, on a test, I'll almost always hedge my bets, list my data, carefully show my work because I'm the king of making dumb mistakes and I want to avoid that on a test. But Gianluca, in my homework, I want to try and push the boundaries. Sure, why not? The other acronym that I use is DULP. Does anybody remember what DULP stood for? Draw a little picture. When in doubt, DFIC and DULP. DULP. Draw a little picture. I don't always need to draw a little picture. Sometimes I'll be able to visualize stuff enough. I'm good. So, example 1, a dragster has an acceleration of 18 meters per second squared. It begins from rest. How fast will the dragster be going after 2.1 seconds? I almost always begin, we're going to DFIC, we're going to list our data, and I almost always start out by saying, hey, what are they asking me to find? What are they asking me to find here? How fast is not anything on my formula sheet. Nowhere on my formula sheet does the words how and fast appear. So let's say it in terms of physics. I heard somebody say VF or final velocity. So I usually write down, to show that, I go VF equals question mark. My question's no longer blank. I feel better. Now I'm going to list my data. What else have they told me? As I scan through this question, I see the number 18. Hopefully, Mr. Kamosi, I'm pretty sure he did, I know I did. I emphasized to my students in Physics 11, it's really worth memorizing what units go with which quantities, because I don't even really see that 18. What I see is the meters per second squared, and as soon as I see that, I know that that 18 is what? It's acceleration. You are going to be learning coulombs, volts, amps, Teslas, Webers. About 10 more units this year, so it's worth keeping this trick going. You can write the units in your DFIC. I generally don't because I'm lazy, although I probably do if I'm on a test. Are we writing the test right now? Yeah, okay. That second sentence, it begins from rest. That tells me something.
Velocity initial is 0.
VI is 0. I like that. Did they give me anything else? Oh, how do I know? Seconds. So I'm looking for an equation that has V final, A, V initial, and T in it. Hey, this one's not too bad. Pretty sure I can go like this. And the VF is already by itself, which is great. So I'll just write the equation. Now I'll start to fill in my numbers. V final equals 0 plus 18 times 2.1. Oh, let's talk Sig Figs. Okay? Remember Sig Figs from last year? We are going to decide this year, because most of the time the questions that we're being given, we won't know what the measurements are. We're going to put all of our answers to 2 or 3 Sig Figs. If you give me your final answer to 2 or 3 Sig Figs, then I'm good. Okay.
37.8.
37.8 units. Units. Meters per second. Nice walk down memory lane. You did a bunch of these last year. B, how far will it have traveled after 2.1 seconds? What do they ask me to find now? Probably displacement if I'm really going to be fussy, but I am the king of mixing up the words distance and displacement. I don't mix it up mathematically when I'm doing the arithmetic, but you're going to hear me time and time again. I keep velocity and speed straight. I'm very careful on that. For some reason, my brain just can't handle the distance displacement thing. Anyhow, so I'm going to write down D equals question mark. If I'd turned the page, I might relist my data. Are we still on the same page? Is the data right above me? I'm not going to relist it. So I'm looking for an equation that has to have a D in it, and then has an A, a VI, a T. If it has a VF, that's okay, but I'd prefer not to. I want to hedge my bets. Just in case I got V final wrong, I might not want to use it to get another wrong answer. So if I have to, I will. Is there an equation that has D, VI, A, and T in it? What? Yeah, I got the distance part. Thank you, Captain Obvious.
D equals VI T plus AT squared.
Oh, and I can do that, yeah? Why? Woohoo! Is the d by itself already? Oh, great. Let's crunch. 0.5. What was the acceleration? 18. T squared. 0.21, Mr. Duke. 2.1. Squared. 943. 36.4? I'm doing bad arithmetic. What is it? 39.7? Okay. I'd like to see how close I can get in my head with decimals. Units page? Yeah. Is she right, by the way? And 3 sig figs had rounded off properly? Yeah? Okay. Turn the page. By the way, these numbers are accurate. I Googled them. So a dragster does actually have an acceleration of about 18 meters per second, just shy of 2 Gs. That's an average acceleration, because in real life, the dragster's acceleration does change. It's maximum at the beginning. It's, forget it. We're in our magic physics world where I told you most of what I teach you is going to be wrong. Keeps the math nice. How long will it take the dragster to reach a velocity of 126 meters per second? What did they ask me to find now? Oh, okay. Did we turn the page? Yeah, okay, let's quickly relist the data. VI was 0, A was 18. Oh, I got a VF now, I like that, 126. So you're saying I'm looking for an equation that has T, VI, A, and VF in it? Which one? Oh, and do me a favor. If you're going to read it to me, let's see if you can't get the T by itself in your head and read it out to me. We can write down the equation and then rewrite it. That's a waste of time. T equals VF minus VI over A. I'm in. 126 minus 0 all over 18. 126 divided by 18, that's going to be the same as 63 divided by 9. 7 even, yes?
Yep.
No.
7.
No. Why would I mark this wrong? So I would have to take a half mark off. What did I say I want all your answers to be? 2 or 3 sig figs.
10.00.
Usually I just go, if it's an even number, I go just to put the 0.0 on there. Yeah, 0.00 is fine too. Okay. I'll be fussy on your tests and quizzes. It's because they used to take marks off on the provincial, so I've stuck with it. It's an easy habit to develop, and 2 or 3 sig figs is actually a nice way to go. Pardon me?
Like, if they're getting the right answer, why does it matter if they put a 0?
They didn't get the right answer. No. The answer is what I say it is.
They don't do that on the provincial anymore.
Well, there's no provincial anymore.
Oh, yeah.
Okay. D, how far will the dragster have traveled once it hit? Oh, how far? That looks like a displacement. Oh, and they did give me a new piece of data. They gave me 153. What's that? Okay, I'll write that. Whoa. Software update. No, that can wait. And I got all the previous stuff. Is it right above me? Okay, then, Joe, I'm not going to rewrite it. I'm looking for an equation that has a D in it, a VF, an A, and a VI. I don't know T.
I don't know, it's up there, it has like little zeros beside these.
Oh, okay. VI is also called, if you're British, V0, V0. In fact, I had a British physics teacher, and you'll hear me say every so often V naught. I'll even say it with a British accent because that's how I learned how to say it. I still don't know how to say lambda. Anyways. V naught, V0, V initial, those are interchangeable, okay? So on the provincial exam formula sheet, they went with the convention from British physics, which is V and V0. I like VI and VF. We'll flip-flop. Anyways, good question. Meanwhile, which equation? Square, okay, get the D by itself. I think minus VI squared divided by 2A. I'm pretty sure you didn't say the squared, punk. And the reason I'm making fun of you is it's amazing how many kids write the squareds and don't type the squareds on their calculators. Every so often this year, as I'm going and handing back tests, you'll see someone look at their test, and in huge letters about this big with 10 exclamation marks, it'll say, squared! And it probably means they wrote everything right, but the answer that they got is what you would get if you forgot to press the squared button. Drives me crazy! Okay, V final, 153 squared minus 0 squared, which is 0, all over 2 times 18. All right. 153 squared divided by, I know that 2 times 18 is 36, so I'm going to do some of the arithmetic in my head because I like to. 650.25 would be incorrect because that's 5 sig figs. Okay, I'll go with 6.5 times 10 to the 2 meters, or you could have said 650 meters, good with that too, or 650 decimal point meters, that'd be the 3, that's fine. When the dragster hits a top speed of 162 meters per second, the chute is deployed. If it takes 12 seconds for the dragster to come to a stop, what's its average acceleration? How long does it travel? Okay, this is a two-part question. I think what I'm going to do is I'm going to divide it into part 1, and I'll be organized. So first thing we're going to find is its average acceleration. Usually, if they give me a multi-part question, I want to find the first thing that they're asking first, because often I'll use that to find the second part. Not every time, but like 90% of the time. So, let's defic a little bit here. 162, what's that? What's the 12? And they're asking me to find, and they did tell me one more thing. You see it? Sorry, I did this wrong, didn't I? Mr. Dewick made a mistake. I never make mistakes. VI is 162, and VF is 0. Sloppy, Mr. Dewick. Okay, so I'm looking for an equation that has VFT, A, and VI. Oh, and let's get the A by itself. Sure. Which is going to be 0 minus 162 divided by 12. 0 minus 162 divided by 12. And I get negative 13.5 meters per second squared. What's the negative telling us? We're slowing down. Not downwards, because we're not in free fall. We're slowing down. We're accelerating backwards. Traveling forwards, accelerating backwards. One of the things kids, especially in Physics 11, have a tough time wrapping their brain around is you can be traveling in one direction and accelerating in the other direction, no problem. Part 2. How long does it have to travel before it comes to a stop? That sounds like a... Okay. So I'm looking for an equation that has D in it, and then V, T, VF. I'll use the A if I have to, because I am pretty sure, Nico, that I'm right. But if I was on a test, I'd probably try and see if I could not use the A, just in case I got it wrong, see if I can find it without it, right? I'm a good test writer. Is there an equation that has a D, a VI, a T, and a VF in it? Is there? Do you guys have the D equals bracket VI plus VF over 2 times T? Well, since they told me it takes 12 seconds, how long is a vague phrase, but I said, well, I don't think they'd want me to regurgitate the 12 seconds. How long? And it should be how far does it have to travel? Yep. Good question. I actually worded that one vaguely on purpose, though. On tests, I'll be clear. But, you know, sometimes, okay, well, how long's got to be a distance? Because otherwise the answer is 12. Do we have, you got your formula sheet handy? Go peek. Oh, we don't have the one from Physics 11 that had the VI and the T. So I guess, you know what? Let's be confident that we did acceleration right, and let's use the one with acceleration in it. Let's use D equals VIT plus a half AT squared. It's going to be 162 times 12 plus 0.5 times negative 13.5 times 12 squared. How far do we travel? Zach? 100, I missed that. 972? Anybody else? Is he right or is he wrong? Is he right? It's Zach, I'm not sure. Okay. 972. We just did in, what, 20 minutes what you spent like a month and a half doing last year. Example 3. Here is your first, attention span here. Here is your first using principles of physics, convince me right to explain questions. Here's what it says. An object starts at rest. You know what? I almost always underline the phrase at rest because that's important. It tells me an awful lot. And accelerates east at a constant rate. If they give me compass directions, I almost always, somewhere in the margin, do the compass rows because the number of times I have dumbly gotten west and east mixed up would amaze you. When it has traveled 10 meters, it's moving at speed v. How fast will it be moving when it has traveled 20 meters? Select the best answer. V, more than 2v, exactly 2v, or less than 2v but more than v. And then it says, and explain your answer using appropriate principles of physics. Or in other words, convince me. So let's read this again. Object starts at rest, accelerates east at a constant rate. When it's traveled 10 meters, it's moving at speed v. How fast will it be moving when it has traveled 20 meters? It says v, more than 2v, exactly 2v, or less than 2v, but more than v. Here's what we're going to do. You're going to vote, okay? And how high you hold your hand is how sure you are of your answer. I'm positive. I'm pretty sure. I'm only voting because I know Mr. Dewick is watching, and if I'm too lazy to put my hand up, he'll make fun of me and damage my self-esteem, so I better at least make a guess of an opinion. Okay?
That's all grade 9 students and teachers.
Who says
Head down
A?
to the multi-purpose room.
1. Who says B? None. Who says C? 18. Who says D? Can someone add those numbers up? I got 9 wimps in this class. You got 30 students? Man. 9 of you. Get a backbone. So the rule is you can either attack someone else's answer or you can defend your own answer. You can either convince or attack. Convince me or attack someone else. Convince me someone else is wrong or that you're right. Anybody? Raise your hand and give me an opinion. Yeah.
It's moving at a constant rate, and if it's at 10 meters, it'll be 1v, and then if it's moving at a constant at 20, it'll be 2v.
Convince me. Here's what you said.
Yeah.
The answer is right because I'm telling you right now that the answer is right. I'm pretty sure if I translate that, you said, well, it's moving at a... You started out good. And then you said, so it's moving at 1v, at v, at 10. It's got to be moving at 2v at 20 because that's the answer. Okay, how can we handle this? One possible way, and eventually many of you will reach an algebraic proof, but one possible way would be to make up reasonable numbers. How about I let the acceleration be, what would a nice number to do math with be? I would probably use 2 or I would use 5. I wouldn't use 10 because there's already a 10 in the question and I'd be worried I might get them mixed up or I might fluke into a bizarre answer. I wouldn't use 1 because that might fluke into a bizarre answer. So sure, how about 2? Which means if our acceleration is 2 meters per second squared and our distance is 10 and VI is 0, what would V final be after 10 meters? Is there an equation that has A, D, VI, and VF in it? Oh, yeah. We got the squared one. VF squared equals VI squared plus 2AD. Although, VI is 0. So really what I have is VF squared equals 2AD. Oh, this is twigging me now maybe to how I can approach this, because I think what we're really saying is that VF is going to be the square root of 2AD. Yes? So now, if I'm trying to convince myself, I'll put a little heading right here, D equals 10. I'll put a little heading right here, D equals 20. I've given a bit of an algebraic start, and now I can say velocity at 10 is going to be the square root of what? 2 times 2 times 10. It's going to be root 40, or whatever the heck that is a decimal. The velocity at 20 is going to be the square root of 2 times 2 times 20, or root 80. You know what? I'm good at handling square roots. Some of you aren't, so why don't we decimalize these, please? What is the square root of 40 to 3 Sig Figs? It's going to be 6 point something. 6.32, rounded off properly. What's the square root of 80? It's going to be 7 point something. No, 8 point something, sorry. Just below 9, because square root of 81 is 9. 8 point what? 8 point? Yeah, I don't care, really, but you're right, I did, because I was already moving on to the 80 in my head. See how my brain works? 8 point what, sorry, Paige?
8.94.
Okay. What's the correct answer? Who was the person who picked D, or the couple of you? Good. Example 4. This would be considered probably a scholarship type question. This would be, if you're asking me on this topic of distance and velocity and acceleration, what would I consider not fair game for the written section of the test? What might I consider fair game as the nasty multiple choice question on the test, but only one like this, not 5 like this? Okay, see where I'm coming from? By the way, you're going mostly to university. You need to learn how to deal with a curveball on a test, something that you know the parts of but have never seen before but can put together. So I'm going to hammer you with that this year a little bit because it's a great skill to develop. And unfortunately, it's a painful skill to develop. The only way to develop it is to get them wrong a few times. Welcome to it. 2 cars are at rest facing each other, 300 meters apart. Car 1 accelerates at 6 meters per second. up to a maximum speed of 30 meters per second. Car 2 accelerates at 5 meters per second squared. I think I forgot the squared on the first one. Up to a maximum speed of 35 meters per second. How long does it take the cars to meet? Assume they are in different lanes so there is no crash. Now, you did this a little bit last year with something called relative velocity, but last year when you did it with relative velocity with cars approaching each other, we started them off at a constant speed. We didn't throw in an acceleration. Can you visualize what's going on? I think what's going to happen, car 1 is going to speed up, 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 and then go to a constant speed. And I think what I'd like to know is how much of that 300 it's covered before it hits its maximum speed. Car 2 is going to do the same thing. It's going to speed up, 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 speed up. And then it's also going to come to a maximum speed. And I think I'd like to know how much of its distance it's covered at a maximum speed. I think I'd also like to know how long it takes for each of them. If we're lucky, it's the same amount of time. If we're not, well, do some thinking. How about yeah? Trying to be organized, Courtney, and now it's no longer blank. I feel better. Hey, let's defic car 1. Let's defic car 2. Car 1, A equals 6. Oh, and VI is 0. And VF is 30. And I'd like to know D, and I'd like to know T. I'm not sure I'll need both of those, but my gut is I will, and I suspect once I got one, finding the other won't be too big an issue. Car 2 is A equals 5. V final equals 35. VI equals 0. And I want to know D, and I want to know T. Okay. I think for car 1, T is going to be easier to find than D. I think I'll find T first, and then once I have T, I'll use it to find D, because I'm pretty sure in car 1, T is going to be VF minus VI over A, yeah? Which is going to be, you know what, I'm going to draw a little line down the middle, because I can already see I'm going to overlap and get confused. 30, oh, good gosh. 30 minus 0 over 6, no calculator. What's the time it takes? Is that my final answer? Then I don't care about Sig Figs. It's not my final answer yet. You can go 5.0, but I Sig Fig my final answer. Oh, and that means D equals a half AT squared. What happened to the VIT? It's 0. You know what? I'm not going to bother writing it. I'm in the big leagues now. Oh, I think I can do this in my head. It's going to be 0.5 times 6 times 5 squared. 5 squared is 25. Half of 6 is 3. I'm pretty sure it's 75 meters. Didn't need a calculator. It would be wonderful if T equals 5 for the second one. That would really simplify things a lot. And you'll see why in a second. T equals, well, I wrote the equation over on this side, so I'm going to go straight to plugging in numbers. 35 minus 0 all over 5. Dope! Rats. Oh, and D equals a half times 5 times 7 squared. 7 squared is 49. Half of 5 is 2. Well, 49 times 5 is going to be 245 divided by 2. Am I going with 122.5? No, I'm wrong. What is it? 122.5? Who the man? Woohoo! All right. Any suggestions or thoughts now? I mean, this is good. We got to start. We got some information.
Break it down to the velocity per second.
Thinking about that, you know what? Let's look at the first 5 seconds, the smallest time. And I'm going to really muck up my diagram a little bit. So after 5 seconds, how much distance has car 1 traveled? 75. After 5 seconds, how far has car 2 traveled? Careful, not 122.5. You know what? Let's put a 5 instead of the 7 right there. Can someone crunch in 5 seconds? Oh, wait a minute. Oh, yeah, that'll work.
7.5.
Let's see. 5 times 5, 5 squared, 25. Sorry, what?
87.5.
So you know what? I'm going to write down here, D at 5 seconds is 87.5. 87.5 meters and meters. I don't know. 62.5? I didn't do the math in my head that time. You see, the reason I'm breaking it down this way is it seems to me for the first 5 seconds, the same thing is happening to both cars. They're both still speeding up. Yes? Then at 5 seconds, it changes. Car 2, still speeding up. Car 1, constant speed. Okay. So after 7 seconds, how far has car 2 traveled? 122.5. After 7 seconds, how far has car 1 traveled? Well, it's gone 75 meters in the first 5. Now it's going at a constant speed. How fast? 30 for how many more seconds? 2. How many meters will it cover? 60 more? Let's put that 60 underneath, Mr. Duke. So here's what I think. I'm going to do another sketch down here. If I got my cars, here's car 1, car 2. I think at time 7, here's what I have. How far have we traveled with car 1? Grand total. 135? How far have we traveled with car 2? 122.5? Have they met yet, by the way? What's the total distance between them? What was it? They're close. They're close. Is car 1 accelerating anymore, or is it traveling at a constant speed? Is car 2, after 7 seconds, accelerating anymore, or is it traveling at a constant speed? You mean they're both at a constant speed? Hey, now it's a Physics 11 relative velocity question. The rest of it. The rest of it. Oh, what's the distance between them? .5 meters. How fast is their combined speed? Remember doing these last year? We said the easy way, by the way, was to pretend one was standing still and the other one was traveling both speeds combined. What's their combined speed? What is it? V combined, or V relative, you called it last year. 65 meters per second. The distance we have to travel is 42.5. What's my acceleration now? Remember? 0, because we're at a constant speed. Oh, can I find how long it would take to travel this? Yeah. Can you give me an equation that has V, D, A, and T in it? Oh, I think we have this. Isn't it just going to be, what? D equals VIT plus a half AT squared to get the T by itself. Isn't it going to be D over V? You okay with that, Nico? Yep. Distance, 42.5 divided by velocity 65. Once they stop accelerating, how long do they travel before they hit? Point? Give it to me at 3 sig figs, or is that even? 0.65 what? So 0.654, round it off properly. So let's recap. How long does car 2 travel still accelerating? How many seconds? 7. Car 1 travels 5 seconds, and then we add an extra 2 seconds at a constant speed so that we can start timing them both at the same time. So they've traveled for 7 seconds. How much longer do they have to travel before they hit? 0.654. That's a nasty question. But you can see if we approach it right, if we don't panic, if we take our time, it's doable. That's a plus sign. Welcome to my messy writing. Okay. Am I going to give you one like that on the test, Rob? Not on the written. And you know what? I'll be honest. That's even overkill for the multiple choice. I would expect all of you to hopefully have followed my explanation, though. And I'd expect the best of you to have been able to actually handle this. What's your homework? Number 1, 2, 3, 4, 5 is good. 6 is good. So 1, 2, 3, 4, 5, 6. 9 is good. Do I want to do the playground question? Nah, I'm good. You can, if you really wish to, write small. You can do these right on here somewhere. Most people just do it on a piece of paper. Or if there's a diagram, they'll do the diagram question on here. They'll do it, the rest of the questions on a separate piece of paper, and they'll just staple them together. You got about 15 minutes left.